So this is the Chapter 10 review. Number 1 says, Anne claims that a store brand fertilizer works better than homemade compost as a soil enhancement when growing tomatoes. To test her theory, she plants 2 tomato plants in each of the 5 planters. When one plant in each planter is grown in soil with a store brand fertilizer and the other is grown in soil with homemade compost, with the choice of soil determined at random. In 3 months, she will harvest and weigh the tomatoes from each plant. Which of the following is the correct confidence interval Anne should use to analyze these data? I have a 2-sample Z interval, a paired Z interval, a 2-sample T interval, a paired T interval, and then the correct interval cannot be determined without the data. Because I am putting 2 plants in the same planter with different soils, this one is pairing them. And because we are looking for quantitative variables, this one is a T interval. So this answer here is D. Number 2 says the weights in pounds of 3 adult males are 160, 215, and 195. What's the standard error of the mean for these data? So the first thing I want to do is find the mean of the data. Since it's only 3 numbers, I will do this by hand. So I want to take those 3 numbers and divide by 3. Which gives me 190. Then I need to find my standard deviation. To do this, I'm going to take each of those and find the difference from the mean. And then I want to go ahead and square those values. This is going to give me 900. I don't know, 25 squared. And 5, 25. I want to add those 3 values up, which gives me 1550. Then I want to go ahead and divide by n minus 1. Which gives me 1550 divided by 2, which gives me 775. And then I want to go ahead and take the square root of this value, which gives me 27.839. And then I need to find my standard error. So that is taking that standard deviation I just found, the 27.839, dividing by square root of my sample size. There was 3. Which gives me 16.07, which is answer D. Number 3 says I want to compute a 90% confidence interval for the mean difference in height for mothers and their adult daughters using a random sample of 30 mothers from, that's just written there twice, random sample of who have an adult daughter. What critical values should you use for this interval? So this one, I am going to use a T-star for 29 because my degree of freedom is 30 minus 1. So I'm going to go look at, on the back, I have this table. I have a degree of freedom of 29, and then I'm looking for a 90% confidence interval, which is, let me grab my ruler. $1.699. Number 4 says we want to construct a 1-sample T interval for a population mean using data from a population with unknown shape. In which of the following circumstances would it be inappropriate to construct the interval based on an SRS of size 14 from the population? A. A stem plot of the data is roughly bell-shaped. B. A histogram of the data shows slight skewness. C. A black spot shows that the values above the median are much more variable than the values below the median. D. The sample standard deviation is large. E. The sample standard deviation is small. So for this one, if my sample size is small, I know this because it's 14, I shouldn't do it if it's skewed. So, this answer here is C. That is a strong skew. Number 5 says a 90% confidence interval for the mean of a population computed from a random sample is found to be 90 plus or minus 30. Which of the following could be a 95% confidence interval based on the same data? So looking at this, I want to have a larger margin of error, but it shouldn't be double the size of a 90%. This is confusing with the 90. So, larger than 30 shouldn't be these two, and it shouldn't be more than double. So it can't be D. It could be C, because this is more than margin of error. Margin of error. Moving on to number 6. This one says, do high school seniors with part-time jobs spend less time doing homework per week on average than seniors without part-time jobs? For a random sample of 45 seniors with part-time jobs, the mean amount of homework is 4.2 hours with a standard deviation of 3.8 hours. For a random sample of 45 seniors without part-time jobs, the mean amount of homework time is 5.8 hours with a standard deviation of 4.9 hours. Assuming the conditions are met, which of the following is the correct standard of error for a 95% confidence interval with, for a difference in means in the population means? So my formula here is going to be square root of my first sample standard deviation. No. Yeah, my first sample standard deviation, which is 3.8 squared over the square root. Nope, not over the square root. I'm in a square root. Over my first sample size, so that one was 45. And then plus, I'm always adding under radicals, my second standard deviation, which is 4.9 squared over that sample size, which again is 45. So I want to look for which of these answers matches. This one has a minus. This one is the same as what I just wrote, just addition, remember, is commutative, so order can change. This one is my answer. Number 7 says, few people enjoy melted ice cream. Being from the sunny state of Arizona, Megan and Jenna decided to test if generic vanilla ice cream melts faster than Breyer's vanilla ice cream. At 10 different times during the day and night, the girls put a single scoop of each type of ice cream in the same location outside and timed how long it took for each scoop to melt completely. When constructing a paired t-interval for a mean difference using these data, which of the following distributions should Megan and Jenna check for normality? 1, the distribution of melt time for the generic ice cream. 2, the distribution of melt time for the Breyers ice cream. 3, the distribution of difference in melt time. So for number 7, my answer here is C, 3 only. This is because when I'm constructing a confidence interval for a mean difference, the distribution of the difference in melt times needs to be approximately normal. So that's the one I'm going to check. Number 8 says a Census Bureau report, not repot, they're not plants, on the income of Americans says that with 90% confidence, the median income of all U.S. households in a recent year was $57,005 with a margin of error of 742. Which of the following is the most appropriate conclusion? 90% of all households had incomes in the interval 57,005 plus or minus 742. We can be sure that the median income for all households in the country lies in the interval 57,005 plus or minus 742. 90% of the households in the sample interviewed by the Census Bureau had incomes in the interval 57,005 plus $742. The Census Bureau got the results $57,005 plus or minus 742 using a method that will capture the true median income of 90% of the time when used repeatedly. 90% of all possible samples of this size would result in a sample median that falls within $742 of $57,005. My answer here is D, and it doesn't tell us the population median for sure, and it doesn't tell us what the individual incomes are. It only gives a possible value. The key word here is when it's used, two keywords actually, used repeatedly. So this tells me how often I should get values between those range. Number 9 says a quiz question gives random samples of n equals 10 observations from each of 2 normally distributed populations. Tom uses a table of t-distribution critical values and 9 degrees of freedom to calculate a 95% confidence interval for the difference in the 2 population means. Janelle uses her calculator's 2-sample t-interval with 16.87 degrees of freedom to compute the 95% confidence interval. Assume that both students calculate the intervals correctly. Which of the following is true? A. Tom's confidence interval is wider. B. Janelle's confidence interval is wider. C. Both confidence intervals are the same width. D. There's insufficient information to determine which confidence interval is wider. E. Janelle made a mistake. Degrees of freedom has to be a whole number. So with this one, when you have a smaller degree of freedom, so Tom had 9, and she has 16.87, the t-star will be larger, and the confidence interval will be wider. So my answer here is A. If you're using a calculator, you can get degrees of freedoms that aren't whole numbers. If you're using the table, that's where you'll get whole number t-values. Or not t-values, degrees of freedom. Okay. Number 10 says the makers of a specialty brand of bottled water claim that their mini bottles contain 8 ounces of water. To investigate this claim, a consumer advocate randomly selected a sample of 10 bottles and carefully measured the amount of water in each bottle. The mean volume was 7.98 ounces, and the 95% confidence interval for the true mean volume is 7.93 to 8.03 ounces. Based on the sample, which of the following conclusions best addresses the maker's claim? A, because 7.98 is in the interval, there is convincing evidence that their claim is correct. B, because 7.98 is in the interval, there is not convincing evidence that their claim is incorrect. C, because 8 is in the interval, there is not convincing evidence that their claim is correct. D, because 8 is in the interval, there is not convincing evidence that their claim is incorrect. E, because 0 is in the interval, there is convincing evidence that their claim is incorrect. So, this one, I don't care what their mean volume was. That's how you find your confidence interval. What I do care about is their claim, which is 8 ounces of water. Because 8 is in this interval, and I don't have sufficient evidence to say it's either greater than 8 or less than 8, no. Hold on. Yeah. Because I don't have good evidence to say it's strongly one way or the other, my answer here is D. There's not convincing evidence that their claim is incorrect. So for all we know, their claim could be correct. Number 11 says many people have asked the question, but few have been patient enough to collect the data. How many licks does it take to get to the center of a Tootsie Pop? After some intense research, a researcher revealed a 95% confidence interval for the mean number of licks to be 317.64 licks to 394.56 licks. A wants me to interpret this confidence level. So what I want to write here is if we were to select many random samples of the same size, from the population of all Tootsie Roll Pops, and construct a 95% confidence interval using each sample. About 95% of the intervals would capture the true mean number of licks required to get to the center. Okay, B wants me to calculate the point estimate and margin of error used to construct the interval. So to do the point estimate, I'm going to take the two values and add them together and divide by 2. Which gives me 356.1. Then I want to go ahead and do my margin of error, which I'm going to take the larger value and subtract my point estimate. Which gets me 38.46. Part C wants me to name 2 things that researcher could do to decrease the margin of error. Discuss a drawback of each. So the researcher could reduce the margin of error by decreasing the confidence level. by decreasing the margin of error. Confidence level. The drawback would be he's not as confident in the interval, not as confident that the interval will capture the true mean. And then another thing he could do is by increasing the sample size. This one, the drawback is larger sample sizes take more time and cost more money. So my last question says, no, not my last question. I have two more. My next question says, a milk processor monitors the number of bacteria per milliliter in raw milk received at the factory. A random sample of 10 1-milliliter specimens of milk supplied by one producer gives the following data. It wants me to construct and interpret a 90% confidence interval for the population mean mu. So the first thing I want to do here is I want to state. There will be a question like either this one or the next one on your test where you have to do the state, plan, do, conclude. So make sure you know how to do that. So my state here is a 90% confidence interval. For my mean, equaling the true number, or the true mean, number of bacteria, per milliliter in raw milk, I spelled milliliter wrong, and I did it again. At the factory. The next thing I want to do is I want to do my plan. So this is a 1 sample t interval. And it is random because it tells me the data comes from a random sample. 10%. So then this is my sample size. 10 is less than 10% of all 1 milliliter specimens that arrive at the factory. Then I want to do a normal large sample. So for this one, I am going to draw out a dot plot. And then I want to, oops, this is off the screen. I want to label my dot plot. Now I actually want to put my dot points on. So for the most part, spread out evenly with a peak in the center. So this is not showing any strong skewness or outliers. I want to go ahead and do my do. So I need to figure out my mean, standard deviation, and sample size. I am going to do this on Stapplet. I believe on the test they will be given to you. I will let you know in class when I actually check the test. So, I'm going to write, we compute from the data. My mean is 4,950. And my standard deviation is 268.5. I know my sample size is 10. So then I have a degree of freedom of 9. And my t-star is going to be sample size of 10, or not 10, 90% confidence interval. So if I go look at this, sample size of 9, 90% is this one right here. So 1.83, ooh, that's crooked, but 1.833. So then then I want to write out my confidence interval. Oops. So I take my mean, and then I add my t-star times my standard deviation, which is 268.5, divided by the square root of my sample size. So if I calculate just the part right here after the plus or minus, I'm going to type that in my calculator. Which gives me 155.63. And then I want to go ahead and actually add and subtract to get my interval. The first one I want to do to get my left value is subtract. So I'm going to do 4,950 minus the 155.63. That gives me 4,794.37. Then I'm going to do the same thing and add in the middle. Oops, I said add. This one gives me 5,105.63. Then I just need to write my conclude. So we are 90% confident that the interval from 4,794.37 to 5,105.63 bacterial per milliliter captures the mean, which is the true mean number of bacteria in the milk received at this factory. Oops, off the screen. Moving on to my real last question this time. It says, researchers wondered whether maintaining a patient's body temperature close to normal by warming the patient during surgery would affect rates of infections of wounds. Patients were assigned at random to two groups, the normal thermic group, where their core temperatures were maintained at near normal, which is 36.5 degrees Celsius, using heating blankets, or the hypothermic group, where their core temperatures were allowed to decrease to about 34.5 degrees Celsius. If keeping patients warm during surgery alters the chance of infection, patients in the two groups should show a difference in the average length of their hospital stays. Here are the summary statistics on the hospital stay in number of days for the two groups. So I have the two groups, sample size, the mean, and the standard deviation. A wants me to construct and interpret a 95% confidence interval for the difference in the true mean length of hospital stay for normal thermic and hypothermic patients like these. So first thing I want to do is I'm going to do my state. Whenever it asks me to construct an interval, I'm going to do state plan do. So I have a 95% confidence interval for my difference in means, So mean 1 minus mean 2. And then I need to explain what my means are on the test. If you give me a confidence interval for a difference of two means, I will mark off points if you don't tell me what the two means are. So my first mean is the true mean hospital stay. For patients like these, who get heating blankets during surgery, and mu2 is mu2. The true mean hospital stays for patients like these who have core temperatures reduced during surgery. For patients like these. Who have core temperatures reduced. Okay. Then the next thing I want to do is I want to write my plan. So it's going to be a 2 sample t interval. For my difference in means. And then I need to check that it's random. Patients were assigned at random to the normothermic group and the hypothermic group. Then I need to see normal large sample. Because I have 2 different groups I'm looking at, I want to make sure both of their individual populations are larger than 30. Oops. So for my first sample, it is 104, which is greater than or equal to 30. And then my second sample is 96, which is again larger than or greater to, not 96, 30. Now I want to do my do. My X bar 1 is 12.1. My standard deviation, 1, is 4.4. My sample size is 104 for my first group. Then for my second group, my X bar is 14.7. My standard deviation is 6.5. And my sample size is 96. I can do this on my calculator. So if I go here, I want to go to, oops, not there either. I want to go to statistics. So the button right here. I want to press that. And then I want to arrow over to tests. And I want to do a 2-sample t interval. So that is 0. And then I want to make sure I have selected the statistics instead of the data. And then I want to type in my data. So my X bar was 12.1. My standard deviation for my first sample was 4.4, 104. Then my X bar was 14.7, 6.5, 96. My confidence level is 0.95. And then I want to calculate, which gives me negative 4.16 to negative 1.04. And I want to write that I wrote this on the calculator. And then I got negative 4.16 to negative 1.04. Now I need to write my conclude. So we are 95% confident that the interval from negative 4.16 to negative 1.04 captures the difference in means, which is the true difference in mean length of hospital stay for patients like these. Who get heating blankets during surgery, and those who have their core temperatures reduced during surgery. Okay, so B is asking if my interval in part A suggests that keeping patients warm during surgery affects the average length of the patient's hospital stay, and then justify my answer. And I'm going to look at my interval again. So that was negative 4.16 to negative 1.04. So because 0 is not in this interval, we have convincing evidence. That's the true mean hospital stay. For patients like these, who get heating blankets, during surgery is different than the true mean hospital stay for patients like these who have core temperatures reduced during surgery.